All right, welcome everybody to the Showcase webinar. This is Jonah Hobson from ITI, and we're in for a real treat today. We have the Bechtel Take on Taglines and Load Control with Keith Anderson and Monty Chisolm from Bechtel. I don't want to waste any more time, so let's get going.
Okay, Keith here. Thanks, Jonah.
Hey, no problem, Keith. I'll run through just a couple intro slides, and then I'll turn the screen over to you. So for the new folks on the line, and we had a bunch of them, that's great to see. We just want to tell you who ITI is. So I'll be very brief in this introduction. Every day, the ITI technical and business teams, we work towards the common goal of being the go-to authority on safe crane rigging and load handling operations. We've been absolutely blessed to work with some amazing organizations. As you can see on the slide there, we take a great deal of pride in contributing to their success, even if it's just a very, very small portion. So at the top, I mentioned one of our presenters today is Keith Anderson. Today's webinar is not the first time that Keith and ITI have collaborated. You can see on the slide that the Fundamentals of Rigging Engineering program is the only program of its kind, and ITI is just super excited to brought together some of the brightest minds in the industry as instructors. So Keith is actually the program manager. The program is really born out of his book, Rigging Engineering Basics. So I encourage everybody to just go to riggingengineering.com and check it out. Very unique program format. It's going to allow all full-time employees to participate at their own pace from anywhere in the world as long as you have internet access. So yeah, when you get a chance, look at riggingengineering.com and learn more. So if you haven't figured it out yet, this is the Showcase webinar series. So it's a free monthly technical webinar hosted by ITI Technical Director Mike Parnell, who unfortunately couldn't join us today. He was called away on a project. I have some of our past presentations on the screen there, all of which are available to view. We have a Showcase webinar archive, so we record all of these. You can view them. If anything strikes your fancy on the screen there, please check it out. And today's session is being recorded as well, and hopefully will be posted within 24 hours. So I mentioned we have Monty and Keith at the top of the broadcast. I want to take this chance one more time to thank them both for being with us today. Mr. Keith Anderson is the Chief Rigging Engineer at Bechtel, and he also heads up the rigging group. As stated on a previous slide, Keith's the author of Rigging Engineering Basics, which is the foundational text for Fundamentals of Rigging Engineering. We also have Monty Chisolm on the line. He's from Bechtel as well. Monty's the equipment superintendent, or an equipment superintendent there. He also is the head rigging operations trainer for Bechtel equipment. Very quick background on today's presentation. So, and something to keep in mind as you follow along in the webinar today. Initially, Monty and Keith came to ITI asking for a peer review on today's presentation. So what we've done is posted the PDF version on our forum on iti.com so we could get feedback from all of you, kind of a peer review mode. So I have some screenshots there saying how to go through it. Go to iti.com, you click on the tab on the right, and then the forum window will pop up. This thread is called Taglines and Load Control, appropriate, I know. And then it'll take you into the process, and then you can download the presentation file and enter the peer review there. I will run through the process at the end of the webinar as well and show you guys. And I'll also send out a direct link to the forum. So that's all from me. I want to start today's broadcast just by launching a poll to get a little bit of background on where everybody's coming from. So this, I'm going to launch it right now. So when does your organization specify the use of taglines is the question. So I just opened the poll. The options are there isn't a policy, always when lifting, always except at the discretion of the person in charge, solely at the discretion of the person in charge, or only for lifts at considerable height. And looks like we have a good amount of you are voting there. I'll leave it open for just a couple more seconds. And when I close the poll, we can go through the results. All right, so I'm closing the poll. It looks like 38% said they always use taglines when lifting. That's interesting. That's the highest amount. And then the second highest amount is 29% of the people saying always, except at the discretion of the person in charge. So interesting stuff there. That is all from me. Thanks for bearing with me in the introduction. I am passing the screen over to Keith. And Keith and Monty, why don't you guys take it away?
Okay, well, I hope you can all see this. Thank you, Jonah.
We all see your screen, so you're good to go.
Good to go, yeah. Okay, for a while now, we were looking for some good guidance on tagline use that we could give people in the field. But we didn't really find what we were looking for, so we got our heads together to compile something. And this presentation closely follows the draft document that we came up with. And as Jonah mentioned, there'll be a PDF version of the doc made available to you. It's offered as is. It's still a work in progress, and we would appreciate feedback. Bear in mind, it's simply advice and guidance. So first of all, let's start with the disclaimer. That's going to keep Monty and I and our employer out of legal trouble. So consider this as best practice for the subjects addressed. It's not exhaustive for all possible work activities. Use the content herein, the experience and conditions as presented by the load, the personnel, the work environment, and the equipment when determining the best placement and use of taglines, and always comply with applicable legislation. It may well be that you're going to be bound by some rules and regulations, either statutory rules or the ones you're working under. So this is guidance and advice. It's not the law of the land. Okay, why taglines? Well, freely suspended loads are subject to dynamic and wind forces that can cause them to swing or to rotate, i.e. wind vane, during lifting. And these tendencies need to be managed and controlled. The risks of not doing so include the possibilities of the load striking something or someone, with potentially severe consequences to personnel, load, and or lifting equipment, and so on. And crane booms in particular are very susceptible to being struck, and they may well collapse if they're deformed. To mitigate these risks, it's a requirement, note that it's a requirement, that persons conducting a lifting operation are in control of the payload at all times, ensuring it does not make unintended or uncontrolled movements. You can see on the picture there, they're lifting that load down a shaft. The guys are there at the bottom, and there's a distinct possibility of the load and or the rigging striking the bracings that there are across the shaft. So what is a tagline? Well, I assume all of you pretty much know what a tagline is, but for those who don't, it's a rope attached to a load during a lifting operation to allow a rigger to control swinging and or rotation of a suspended load. And multiple taglines might be needed to exercise full control. This deal here being the tagline, obviously, and this being the model tagline handler. Okay, the purposes of a tagline. We're going to talk about what it is and what it isn't. And taglines are used to, first of all, oppose uncontrolled rotation of a freely suspended load as it's lifted and or maneuvered or relocated under the influence of forces such as wind acting on it. Secondly, to alter the rotational attitude of a suspended load as it's guided along a path or to position it in a particular attitude. Thirdly, to assist in controlling swinging induced during lifting. And fourthly, to avoid the need for persons to put their hands directly on the load to control it, where that would pose a hazard, allowing safe distance between them and the load. taglines are not to be used for pulling a load out of its natural suspended line, inducing in-haul or out-haul of the load lines. As you can see on this little sketch here, he's dragging it out of line. Secondly, it's not to hold a load against wind forces that are trying to push it out of line. You really cannot fight wind forces directly with taglines. Thirdly, you may not use a tagline to contribute to supporting the load. So we're going to have a little bit of a thought here. Let's talk about this lift. Do you think this tagline setup is an effective way to control this steel beam during this lifting operation? Have a little bit of a think about that, and we're going to return to this at the end of the presentation.
Yeah, Keith. Yeah, everybody pay attention to the slide you see on your screen right there. I'm going to launch a poll right now, just a second poll. So try to take in on that picture because I think it'll disappear once I launch the poll. But basically the question is, do you think this tagline setup is an effective way to control the steel beam during this lifting operation? So I'll open that up just for maybe 30 seconds here. Just launched it there, pretty simple. Options are yes and no this time. And looks like we got over half the people voted already, so about 5 more seconds, I'll open it up. And alrighty, that's about 3/4 of you have voted, so I'll close it now. And it looks like the results are pretty clear. 91% say no, and 9% say yes. As Keith mentioned, keep this in mind, and we'll revisit this at the end. So back to you, Keith.
Okay, well, hopefully the slides that follow are going to give you some pointers on that. Good to see that so many didn't think it was under control. Okay, types of taglines, Monty.
Now, ropes used for taglines should be manufactured out of soft fibers, such as synthetic, plastic rope or natural fibers that don't present the manual handling hazards of wire rope. They should be semi-stiff or coated so as not to easily tangle and be in single links, in other words, continuous without knots in the middle of them tying an extra rope on. The types of rope that we want to use, either natural or synthetic fibers, are either made out of hemp or cotton. They're twisted or braided rope, either one of them. Nylon, polyester, and polypropylene. The terminations that we use, mechanical terminations such as hooks, clips, or carabiners. Now these can be load-bearing or non-load-bearing. And also the terminations that we use, either eyes in twisted rope, such as a braided, either a thimble or a soft eye or a turn back eye, and in braided rope, same way. Note that using a tagline with a braided eye in one end does allow us to choke it around, like say steel, for easy control and removal by personnel at heights. Now the knots that are in the rope that we will use to attach the loads, we're going to talk about those later. But there's also availability of retractable taglines, and we have a link on here for those.
Okay, insulating links. Note that a number of companies manufacture insulating links that will help protect tagline personnel from risk of electrocution when operating in proximity to high voltage power lines. You would incorporate these links in the length of the tagline using knots close up to the load. The one you see there is a link made by a company called Insulatus. Note that although the use of insulating links is recommended as an additional safeguard over and above other safety requirements such as maintaining stipulated clearances when working near power lines, there is no perfect assurance that electrocution can be avoided by their use. They are, however, a useful tool to have in the arsenal. So why would a load want to rotate? Well, there's a couple of reasons why a load may want to rotate on the hook as it's lifted and maneuvered. And the main reason why it would rotate is the action of wind forces. So unless a load has the same area to the wind, regardless of rotation, For instance, in the case of a vertical cylinder, it will want to rotate in a wind to present its least area to the wind, which of course is the principle of a weather vane. So for instance, a vertical cylindrical chemical vessel may show little or no tendency to rotate in a wind, whereas a long flat-sided steel beam of the same area may show a pronounced tendency to rotate at the same wind speed. So understanding this is a key factor in deciding whether or not taglines are required to control rotation. Secondly, the load lines may spin up some as the load is lifted. Using taglines, the load can be held static, allowing the spin up to shake out at the bearing in the hook block. There's the 2 points. So here's a couple of graphics illustrating that point. The vessel on the left is vertical and symmetrical. There's no particular reason why that wants to rotate anywhere in the wind, apart from maybe a little bit of load on the spreader there, but the beam on the right will definitely want to rotate to present its least area to the wind, and could quite conceivably get very close to that crane. So the shape is important, not just the area. So before we get too much into taglines, an understanding of the forces is important, because they can be a whole lot different than you might imagine. So let's talk a bit about wind speed, pressure, and the forces induced. The magnitude of the forces and the rotational effects acting on a load when that load is subject to the wind is often not well understood, and underestimation can cause big problems. So time to look at some theory. When a static object is subject to a flowing stream of wind, there is going to be pressure created on it. And there are some formulae here that will allow you to figure out what the pressure will be. They're all the same, it's just different units. The first one there is the United States customary units. The pressure is this figure here, or more easily you can say it's Vs squared over 400, approximately that. So if you want to work out what the pressure is on a load using American units, square the velocity and divide by 400, where the velocity is in miles an hour. For those of you who are metric savvy, this one here is going to give it to you where Vs is in meters a second, and this one in kilometers an hour. And the pressure you're going to get is going to be in newtons a square meter or pascals. And note that the pressure is directly proportional to the square of the wind speed. Note the square sign. So a doubling of the wind speed is a quadrupling of the pressure. So how does that relate to forces acting on the object? The wind force is given by the formula where F equals the pressure times the projected area A times the shape factor or drag coefficient. So the shape of the object also affects the magnitude of the force. So typically you've got a factor of 1.2 for long round pipes, 0.8 for short round pipes, or 2 for long flat plates, or 1.4 for short flat plates. Wind speed is often referred to using the Beaufort scale on a scale of 0 to 12, where 6 is a strong breeze, and that would equate to about 25 to 30 miles an hour. And in the handout we're going to give you access to, there's a guide to the Beaufort wind speeds. We don't give it to you here in this presentation. Note that the standard height at which wind speeds are quoted is 33 feet above grade. So if you see a wind speed quoted, it's intended that it's at that height. Of course, the wind speed you're actually interested in is going to be that's blowing on the suspended load, and that can be a whole lot different to the wind speed down at ground level. Noting, of course, that we've just said the wind speeds are quoted at 10 meters or 33 feet above grade. The wind speed actually increases logarithmically with height according to a curve similar to the following. And what that curve actually looks like depends on whether the air is stable, neutral, or unstable, whether it's over water or land, and whether the site is disturbed by human habitation and so on. In this case, the wind speed at 100 meters or 330 feet, down here somewhere, is twice what it is down at the base level of 10 meters or 33 feet. So this means that the pressure is 4 times that at 10 meters. So you need to be aware of this. For lifting purposes, the wind speed indicated on the anemometer on the boom head should be used, as that's what's actually happening at height. So why would a load want to swing? A load typically takes a swinging when the wind is gusting or when moving with the load on the crane hook. And once started, it can be difficult to stop. Ideally, you want to stop it swinging in the first place, or at least limit the amplitude before it gets out of hand. So, if an unrestrained suspended load is subject to a sustained wind force, it actually moves sideways, inducing an out-of-plumb angle in the suspension. And the forces balance when the horizontal component of the tension equals the wind force, and the load reaches a state of equilibrium at a slight out-of-plumb, so long as the wind continues to act in a constant manner. Of course, the second the wind drops, that force is no longer there, and the whole thing starts to take to swinging. So let's look at an example here. We'll just do it in the US customary units. So if you take a 10-foot by 10-foot cladding panel in a 20-mile-an-hour breeze facing the wind, and assuming a shape factor of 1, there's going to be 100 pounds of wind force acting on that panel, remembering that, of course, the pressure is the wind speed squared over 400, multiplied, of course, by the area gives you the force. That's where the 100 pounds comes from. If the panel weighs 1,000 pounds, the load will move horizontally approximately 1/10 of the suspension height until the forces balance. So if you have a suspension length of about 50 feet, the load's going to move about 5 feet sideways in that wind, which of course is a pretty considerable distance. If the wind drops, it'll tend to return back to plumb, and swinging will be induced. So it's not just the fact the wind is blowing. Gusting is a major issue. So why would a load want to swing? Well, on account of inertial effects. So when you move a load with a crane, the crane moves forward, say, but the load initially stays where it is, which is inertia, until accelerated by the horizontal component of the tension in the now slightly inclined suspension. If the crane suddenly stops moving, the load's momentum keeps it moving, and it will swing like a pendulum until eventually it comes to rest. So to minimize this, an operator should gently accelerate and decelerate the crane so the load keeps up with the crane without swinging wildly. Note that there is a natural frequency to the swing, which is independent of weight and is related to the suspension length. If you're really unlucky, wind gusting can reinforce this natural swing, ever increasing the amplitude of the swinging. You can see that from this that light loads with large sail areas can be particularly problematic. So the takeaway from all this is, don't lift light loads with large sail areas and high winds. If loads start to swing, attempt to damp down the movement. If that's problematic, possibly turn the load to rotate to present its least area to the wind, wait until it stops swinging and then turn it back and try again with improved control. So when to use taglines and when not to. Most of you said, well, I think about a third of you said that you're always required to use them. OSHA in the States says taglines on a load are required where hazards to employees exist in order to keep the loads under control. So it doesn't say you have to use them all the time, it says where hazards to employees exist. In the UK, Lola says, appropriate measures should be taken to prevent a freely suspended load from moving in an uncontrolled manner where the risks justify it. Taglines may be necessary to stop the load swinging, for example with an overhead crane. And the British Standard that relates to cranes says, if one or more handlines or taglines are required to give more control of the load, the appointed person should designate persons to handle the lines. So, a common theme is that taglines are required to control a load where they're needed. On the other hand, where they are not required to control a load, they're not required to be used. That said, I would recommend that they are used unless they would serve no useful purpose and could potentially create a snagging hazard. How many taglines you need, where they should be located and what their purpose is needs to be evaluated as part of the lift planning exercise and should come out of the initial risk assessment. Taglines may, for instance, not be required to stop rotation, but they might be required to receive, steady, and finally position the load, keeping people at a distance. Taglines should, therefore, be used unless they would serve no purpose and could actually create a hazard. What about loads that are suspended from two cranes? Up till now we've been talking about singly suspended loads, but in this case we have a tandem lift. And loads suspended from two or more lifting devices, cranes for instance, will not freely rotate in the wind, but they may swing a little. Trying to use taglines to rotate a load suspended from two cranes is a really bad idea. First of all, you're going to store twist. The second you release the line, the load will revert back to its natural attitude in an uncontrolled manner. Secondly, you don't have the strength to fight the cranes, so you should carefully consider whether the use of taglines in these cases contributes anything useful. Of course, it may be required to control swinging of the suspended load, so that might be your rationale for using them in this case. Putting your hands on the load, manual control. This is one for you, Monty.
There may be instances when it's necessary for one or more persons to put their hands on the load, for instance, say final alignment over anchor bolts. Okay, now trying to do this with taglines could virtually be proved to be impossible, but there's a few things that we need to keep in mind. Number one, never reach above shoulder height to access a load. Place your hands on the surface and never in, on, or under the load, or at the end of a load, especially when swinging or booming. Maintain an arm's length away from the load. Walk the load down. Reaching down also, the same as reaching up, moves you closer to the load. Dynamic effects on the load, such as wind, pendulum actions, and swinging, can put you at risk. Never place any part of your body in between a load and another object, such as a pinch or a crushing point. Make sure that good communication is always maintained, especially when hands are on the load. Keep your fingers, nose, and toes, etc., well away from pinch points. Lowering should only be, or raising should only be initiated at the command of the person in charge and after confirmation that everyone is clear.
You can see here that you've got the guy who's doing the signaling is in clear sight of the guy who's controlling the load here, and also the crane operator. It's important that all the participants in the operation are in good communication with each other.
So how much can we pull? How much force can one person pull? Now, the Ergonomics Center reckons that a man can be expected to be able to pull horizontally a sustained force between 75 and 90 pounds, or 34 to 41 kg, with a rope at elbow height and allowed free position. Note that the surface on which the person is standing can affect this. Now, you can imagine that even with two or more taglines on a load, you won't be able to do a lot directly oppose wind forces on larger loads, even in modest winds. But you may well be able to prevent the load from rotating on the hook. So how much can we pull? So we thought we'd test it out. So I went back here in the warehouse and weighed myself and came out just over 200 pounds, and then took a scale, tied one end of it to a immovable object, and then I got on the other end with it. And you can see my stance here. With a maximum sustained force, a max of force, I got about 90 pounds. A sustained force of about 75 pounds. Our practical test confirmed this, that a 200 man can pull about 90 pounds max when allowed to free stance and when standing on a rough surface. This reduces to about 75 pounds of sustained. Well, I moved inside on smooth concrete where the friction is less and I could pull less. So it's reasonable to project that a lighter man would pull less than this. As a rule of thumb, a man might be able to pull a maximum of about 45% of his weight and a sustained pull of about 35% of his weight. Now this is at a horizontal pull. This is a bit subjective, but it gives some measure to work from. Now if your boots cannot get a good grip on the ground, this can be a lot less.
Yeah, I think all this highlights the fact that what you can pull is a whole lot less than some of these forces we've already been looking at initially, which talks to the point that you can't fight the wind forces, you can merely be expected to control the load. So factors affecting the effectiveness of the pull. So, you know, given that you have a limited ability to pull, you want to make your rotation as effective as possible. And to achieve that, the aim is to make the moment arm as great as possible to give your pull the maximum turning effect about the crane hook. And to explain that, the moment arm is the horizontal distance perpendicular from the point of rotation, i.e. the crane hook, to your line of pull. In other words, you want to be square on to the axis you're turning around. If you imagine in plan view a line from the crane hook to the point of attachment of the tagline, your pull is most effective if it makes a 90-degree angle to that line. Obviously you cannot realistically achieve that all the time, but that's what to aim for. So what am I talking about? Well, if you look down here on the bottom picture, this is pretty effective. You've got the line of rotation is going to be at the center of the bearing here, so it's going to rotate around this axis. Okay, this guy here is on a tagline. He's got his line horizontal, and he's making about a 90-degree angle to the line from here to the point of attachment. So if you imagine that line there, he's making about 90 degrees to it. And this other guy on the other end is doing about the same. But between the pair of them, they can prevent rotation in either direction. You look up here, for instance, and they've got themselves stood off to the end here. If you project that line through, it has a very small distance to the axis of rotation, and it's not going to be very effective at preventing or creating rotation. They need to move around over here somewhere to be more effective. We often see people that are stood like this, and it really doesn't give you a whole lot of load control. Try and get yourself square on if possible. Your limited pull is going to be most effective in that way. Secondly, your pull is most effective when the tagline is near horizontal. And when working at or near ground level, that's pretty easy to achieve. However, much of lifting involves raising the load to height. So the greater the angle the tagline makes to the horizontal, the less effective the pull is in its ability to rotate the load in a horizontal plane. And by the time the taglines are 45 degrees, the pull is only 71% effective. We've got a graphic in a second which will explain this. You should also note that as the angle to the horizontal increases, you're actually pulling down on the load. At 45 degrees, 71% of your pulling force, i.e. the tension in the tagline, is acting down on the load. If you go as far as nearing vertical with a tagline, the pull is all vertical and contributes nothing to rotating or preventing rotation of the load. So you may start in control of the load, but progressively less able to control it as the lift progresses. So you see here, they probably started off in this case pretty effective when they were down at the ground, but by the time it's up here somewhere, that tagline is nearly vertical and is contributing next to nothing in that direction. The pull is all down over on the beam and none of it's out over. And we often see this. I mean, how many times do we see this kind of thing? The guys start off on the ground and the lift goes up, they get less and less effective, the wind picks up, next thing you know the load's taking over from the guys. You need to try and get yourself to this kind of situation whereby even when the load is at height, you still have a fairly respectable pull in this direction. And in this case we're 45, so that's 71%. However, even in this case, when you pull on here, that's going to go down there. And this guy is going to be pulling, it's going to go down there. With two guys, that's actually going to pretty much balance itself out. But that can be something to watch out for in some cases. Rotational effects acting on a load. If the wind pressure is uniform on the load, then the wind force can be considered to act through the center of area of the load as presented to the wind. The axis of rotation of a singly suspended load is centered on the crane's hook block bearing, and that will naturally lie over the CUG. If the center of area lies on the same line, then the wind force has nominally no rotational effect, and the tagline forces are nominal. A load whose center of area lies to one side of the CUG will have wind forces acting to one side of the axis of rotation. To hold that load static against the wind can require considerable force. Do not underestimate this. So what am I talking about? Well, in this case here, we've got some pretty substantial plates on the end of the beam, and that's dragging the CUG towards that end. So in a singly suspended sense, that's going to lie directly underneath the crane hook. So that's where it's going to want to rotate around. The center of area, however, is right there. So the wind force is acting there and is causing a rotation because of the distance from here to the CUG. That moment arm there is causing this wind force to want to rotate that around the hook. So what's going to resist it? Well, if it's trying to go that way, you've got to pull that away or that way. Okay. This guy in this case is positioned where he's most effective because he's the furthest distance away from the CUG. If he was to stand up at this end, he's not as far away from the CUG, and his pull is going to be less effective. Of course, in practice, you're going to probably need him in both places. So let's do a little analysis. We've got the same graphic up here at the top. Let's consider a plate girder, which is 10 feet deep and 60 foot long. That's this girder here. It's got these thick plates up at one end. The CUG is 20 feet from one end. In other words, it's there and it's 40 feet from the other end. So it's 10 feet off center. The center of area is at mid-length, which is there. Lateral forces are thus acting 10 feet offset from the center line of suspension. In other words, that little distance there from the middle of area to the CUG is 10 feet. So let's consider lifting in a 34-mile-an-hour wind, assuming that's what's actually happening right there at the lift. The wind pressure in pounds a square foot is given by that formula there, this one here, or the easier formula, which is V squared over 400, which is the same thing. At 34 miles an hour, the pressure comes out at 2.9 psf, so let's call it 3 psf for the sake of simplicity. So with a projected area of 600 square feet, which is the 60 by the 10, and assuming a shape factor of 1, the force is going to be 1,800 pounds. And that acts right there. Okay, the moment, which is the rotational effect, is that 1,800 times the 10-foot offset, which is 18,000 foot-pounds. If a single tagline is used at the 20 feet end, in other words up here somewhere, the moment arm is only 20 feet. So that guy on that tagline has to provide 18,000 divided by 20, which is 900 pounds. So to stop that thing rotating, he's got to provide 900 pounds of pulling force. Now we just saw that Monty was able to pull, if he was lucky, about 90. So you can see that that's way too much for one person to control. If you put the tagline up the other end here, he's 40 feet away from the axis of rotation, so he would have to pull 450 pounds, which is still way too much. If you reduce the wind speed to, say, 20 miles an hour, the rotation becomes about 6,200 foot-pounds. If you use taglines, one at either end, both resisting rotation in the same direction, i.e. one there and one here, then the required force each has to provide is about 103 pounds, which you might just about achieve. And given that the shape factor is likely greater than 1, and you probably don't have a perfect 90-degree purchase on the load, and the tagline probably is inclined a bit vertically, it would be advisable to have 2 persons on each line. In other words, double up on the guys on the line here. Note also that you may not be guaranteed the load will always want to turn the same direction, particularly if you have to swing the crane. So it may be necessary to provide 4 taglines, one in this direction, one opposing it, one in this direction, one opposing it, with 2 guys on each tagline. Now, I don't know how many people out there would ever have thought that 8 folks might be required on this operation here. So the takeaway is the forces can be a lot more than you ever expected, and you might need more lines and more people than you ever expected. And you might also need to reduce the wind speed for the operation. And remember also that wind speeds increase with height. We're showing here that you're down at ground level. If this was to get to height, you've got that working against you, and also the horizontal angle the tagline makes to the load working against you. So do not underestimate it in this instance. We've got a metric example here for those of you who work in metric system. I'm not going to go through it, but it's there in the accompanying PDF. So other considerations. Guiding a load in a dead calm only requires you to overcome the resistance of the bearing, and you've got a lot of mechanical advantage working for you. In other words, the bearing is small, but you're attached a long way away from the axis of rotation, so you have a lot of mechanical advantage, and the forces should be pretty small. Secondly, once a heavy load is moving, it's got inertia, and it can take a lot of stopping. It's much better to stop it from moving in the first place. So if it does get to moving like that, ease the load where you want it using the taglines. Don't get it moving too fast, and ease back on the pulling before you get where you want to be, and allow the load to decelerate to a stop where you want it. How often do you see someone rotating a load and they're pulling like hell on it? The load comes where they want and the inertia carries it straight past, and then the guy on the tagline has to dash across to the other side of the load to try and pull it back because he's gone too far. Don't do that. Realize that the load is going to continue moving once you stop it, once you stop pulling, and it's gradually going to come to a halt. Thirdly, wind speed increases with height. It should be assessed at the crane boom tip. Further, you might be sheltered at ground level, but exposed as the lift progresses above the surroundings. And don't ignore either that wind funneling can occur around structures, for instance cooling towers. This can cause localized zones of high wind velocities. So when you should decide to lift and when not to lift. As you can see from all the preceding considerations, there's a number of factors that come into play when you're lifting that affect the ability to control the load. And as we said right up front, you have to be able to control it. These factors include the prevailing and predicted wind speed at the height of the lift when conducting the lift. In other words, go out there and see what the wind's doing and also what it's predicted to be doing. We've seen that the size of the load, the shape of the load, and the weight of the load is also important. You've got to consider gusting. You've got to, as I said, load, shape of load, weight of load. How close to capacity is the crane? You know that the crane has its rated capacity and it also has a limited lateral capacity. How close are you working to the capacity of the crane? What about clearances between the load and the crane and structures? If you're working to very tight clearances between the load and the crane boom, or between the load and structures, you're going to want to be pretty conservative in controlling this thing. You might want a real low wind speed, for instance. Is this a single crane lift or a tandem lift? You need to have the ability to locate your taglines and the handlers to maintain adequate purchase on the load during lifting, i.e. you have to maintain effectiveness of your taglines. If you can't do all those things, you shouldn't be lifting. Bear in mind as well that even though the manufacturer may put a limiting wind speed, which might typically be, say, 35 miles an hour, in the crane manual or on the chart, doesn't necessarily mean that it would be safe to lift a particular load at that wind speed. And note as well that some capacity charts are based on a particular limiting wind speed, which could be, for instance, 9.81 meters a second, and an area of the load which doesn't exceed, say, 1.1 square meters per ton of capacity. Those charts typically provide formulae by which a lowering limiting wind speed can be calculated when the load has a greater area. Other charts might simply say, operator judgment to be exercised. If a load cannot be safely controlled, it should not be lifted, and the judgment is going to fall on the crane operator ultimately, and it's necessarily somewhat subjective. It must be respected. Many times we see that the management on the job wants to get the lift done regardless, and they're going to put a lot of pressure on people to get the load done. And they come out with things like, it says in the manual 35 miles an hour, or it's not blowing too hard down here. And they'll put pressure on people to make a lift. At the end of the day, if it can't be done, in the opinion of the crane operator ultimately, in a safe manner, then it shouldn't be done. So respect the judgment of the people that are doing the work. Okay, Monty.
So from all of this, we need to make sure that we do plan our tagline use. So how many taglines are required? All we can achieve with a single tagline is to resist movement of a load away from us. In other words, we're having to pull it to us. It's not acceptable to dart and dash from across the line of the load from one side of the load to the other with a tagline to correct an overcorrection. Remember, you can't push with a tagline. If you do have to push, you may have to put push poles on something. Generally, 2 taglines are required to adequately control a load against rotation. To control swinging, both will have to apply a load to it.
Okay. Of course, anybody handling the load should keep in touch with the load at all times, and in order to apply or resist the load when needed without having to take a whole lot of slack out. So keep in touch with the load at all times.
So remember that if attempting to control a long load at height with a tagline at a steep angle to the horizontal, the force that you apply to the tagline has a horizontal component, and that's what you want. And it has a vertical component, which you don't want. That's trying to drag down the end of the load to which it's attached. Using 2 taglines may help balance this. Now, there are instances, as noted before, particularly on long loads, where 4 taglines may be required, allowing control of swinging in both directions and allowing 2 persons to control rotation in either direction. Good communication is required in such cases. Also note that when erecting steel, generally only 1 tagline is used to receive the steel and then orientate it as needed. Tagline is usually put on the numbered end of the piece so that the connectors know which end goes where. Now, during steel erection, the practice of Christmas treeing steel presents other hazards. A good practice is to bring the bottom piece of steel in at waist to shoulder height of the personnel and then move into place. This prevents the load from having to be lowered over the top of the personnel. Now, in such cases where this is not feasible, allowing personnel to move out of the way and then lower the steel to the required height and then the personnel move in and place the steel in place is another option. This practice does require well-trained personnel who are experienced in steel erection, especially the crane operators, the iron workers, and the supervision.
Okay, where to attach? Tagline should be attached to the load towards its lateral extremes. In other words, as far away from the axis of rotation as possible to get the best purchase against rotation. They should be attached to a load nozzle, structural member, or other substantial and solid member capable of taking a significant force without being deformed or damaged or moving. Tagline should not be attached to the rigging supporting the load unless that's the only option and is assessed to be safe to do so. We're going to talk a little bit about that in a moment. They should not be attached to door handles, valves, or items of equipment, and they shouldn't be attached where they could slip off as the operation proceeds. How long should they be? We often see people going to make a lift and then they realize as it's going up there that the taglines aren't long enough and they let go of them. How long do they need to be? First of all, decide what control is required. Is it required only during uplift and receipt? Is it required through the entire operation? Will control have to be handed off to someone at height maybe? Will I have to let go of the taglines at some point? And if so, will they be a hazard? The taglines need to be long enough to keep your body parts out of harm's way, long enough to reach the load from where it will be to where the handler has to stand with some reserve considering the load height, long enough that the handler can be positioned so the angle of the tagline to the horizontal doesn't get too steep, the control becomes impossible as the lift proceeds, and not so long as to create a snagging hazard. And there should always be a clear line from the handler to the point of attachment so that the tagline does not have to pass over or under or around parts of the load as the operation proceeds. Okay. Where to stand? You want to get that one, Monty?
Certainly. As noted earlier, taglines are most effective if their line of action forms a 90-degree angle in plan view to an imaginary line from the center of gravity to the attachment point. Tagline handlers should aim to position themselves as close to that as possible, consistent with being in sight of each other and the crane operator if possible. As the load is turned or rotated, this angle will depart from 90 degrees and the pull becomes less effective. It may be necessary for handlers to relocate to regain better purchase on the load. Now, moving with the load, as much of lifting involves relocating a load either by hoisting, swinging, booming out, crawling, or some combination of these, tagline use needs to reflect this. The persons handling the taglines will either need to move with the load and or be able to pay out the tagline. Note extent of correctional rotation required between start and finish and plan for it. Plan for guiding the load between obstructions. Plan a clear footpath for the handlers. If duplicate taglines are required, plan to hand over control.
Yeah, the load must not be allowed to take over and drag the handlers along a path of its choosing. Lowering down shafts. Here we see a load that's being lifted down a shaft. This is an excavator. It's being lowered down this tunnel. And you can see the tagline is on, but it's not yet, no one has yet got hold of it. The idea being that when it gets down there, they'll stop, the tagline will be retrieved, and they will then use it to guide the position of it. When lowering down shafts, it may only be possible to effectively control rotation at the shaft opening before lowering and on receipt at the bottom. Rotational control may not be possible down the entire shaft, and the risks that may or may not be posed should be considered. Taglines may need to be released at the top and retrieved at the shaft bottom, as in this case. The potential for snagging of the taglines needs to be addressed. Points to consider in preparing a tagline plan for lowering down a shaft include: how many taglines are required? What rotational swing control or adjustment of attitude is required from uplift to the shaft opening? Okay, how many taglines are needed? How long do they need to be? Where can the handlers stand? Noting that, of course, they can't stand in the shaft opening, they're going to need to be some distance away. How critical is rotational control as the load enters and is lowered down the shaft? Can that be controlled? At what point should the taglines be released, if that's necessary? Will they cause a snagging hazard? Are taglines required for a seat at the shaft bottom? How many, how long, and how can they be safely retrieved? And there needs to be some handover and signaling protocols. Lifting to height. Remember that loads lifted through significant height may suddenly be subject to wind when clear of the surroundings. Bear in mind this graphic is just a graphic and all the handrails and all the rest of it are not shown. But you can see here that when you'd get from the ground up to height, in this case, where's my pointer gone? Here it is. When this gets up to the top here, that may well suddenly pick up the wind. Also remember that as the lift progresses, the increasing vertical angle may render the control ineffective. In other words, these guys can't move any further back. They're limited as to where they can stand, and you need to make sure that even with them stood as far back as they are, that some degree of control can still be exercised. You may need a second set of lines when you get up to height, so you would put a short set on. In this case, the long ones are on the rigging, and we'll talk about that in a minute. The short ones are on the load, and they're on the side nearest to where the tagline handlers are. So we've lifted up to height, we've controlled it to there. Now they're going to retrieve the taglines, and we'll talk about retrieving taglines in a second. And control can then be handed over to these guys. Once you've released the rigging, the taglines can be used in this case to guide the spreader bar as it's lowered back down to the ground again. The potential for taglines to snag on the surroundings when lifting or lowering and manipulating the load has to be addressed. If there's stuff sticking off the side of these buildings or structures, you need to consider whether these little taglines here might get snagged up on them as you're lifting. Receiving a load. The safe way to retrieve a tagline would be to keep your hands away from it, and you may consider using something like these boat hooks here, which is just a shaft with a hook on the end of it. These were actually homemade devices on one of our foreign projects. There's also a deal like this, which is an Australian invention. They put this extension on, in this case to a man basket, and it allows you to provide an attachment point that's remote from the load. The idea being that you can keep yourself from being under the shadow of the load. And remember as well, where possible, stand downwind when retrieving a tagline, so the line's coming towards you rather than away from you. Okay, knots, Monty.
Okay, when to use which knot? Bowlines are used when there is a fixed point, such as a bolt hole or a lug on, say, a piece of equipment to tie to. Clove hitch, single pieces or bundles of round stock, such as pipe, rebar, or any round material. We use a choked loop on single pieces of square stock, such as beams and columns or angle iron. Now I tend to use a figure 8 on a bite when loads on taglines are going to be a lot higher, such as long taglines that are used in conjunction with anchor points, say a dead man or heavy equipment, or a capstan hoist. Now, we talked a little bit about where to attach them earlier. As close to the end of the load as feasible for ease of control, as explained earlier. Also for ease of retrieval when accepting a load. Now, we also tie them to the rigging assembly when we're setting loads with complex rigging arrangements at heights, so that we can control the rigging assembly back to the ground. Shorter taglines may be needed for the personnel at heights to take over control of the load once it's near the setting point. This would also be advantageous when setting loads over power lines. Now, you're going to need to plan this carefully. Remember insulating links and distance away from power lines that you have to stay. Now, at the corners of loads with large sail areas and pieces of equipment that may require more than 2 taglines. How to attach taglines to the load. The use of a bowline or a mechanical hook to a fixed point. Make sure that your attachment points are structural and sufficiently substantial for the forces that you're going to put on it. Secure so that the tagline will not slip off or come off in use, or the attachment point move relative to the load. Make sure that you're not likely to damage, you don't want to be tying to door handles, because if you have to put a considerable load on it, you can damage that, and you don't want to be damaging your tagline itself. So make sure you stay out of the sharp corners. Now here I've got a clove hitch used on a small bundle of pieces of pipe with and without a stopper. Now the stopper, all that is a half hitch just to keep that knot from coming undone. And then on the pictures below, you can see I've used a choked loop either with a tied bowline or a braided eye or a mechanical hook, so that when you do pull down on that, the more force you put on it, the tighter it just gets there. And number 4, I'm connected to the rigging assembly here, and this is a container lifting frame, and so that we can control it to put it over the next load that we pick up. But also we've got a tagline tied to the container itself so that we can control it also if we have to when it gets close to the ground. Now, the use of the figure 8 knot for heavy loads, and also you may want to think about using a thimbled eye here when you're having to put extreme heights, put loads at extreme heights such as wind turbine generators and propellers. Use it with a dead man or a capstan hoist. Now, the figure 8 knot only reduces the capacity of a rope by about 15%, excuse me. The key to tagline considerations, number 1 is the type of load, whether it's a small, short load, beam, straight run pipe, light, long light load like bundles of rebar or small bore pipe, large light loads, sheet steel, form panels or wall panels, large heavy loads such as compressor, lube oil skids or generators, loads at heights, steel erection, setting equipment in or on structures, or wind turbine work. Need to take in consideration the wind conditions, the shape of the load, the travel path, is it clear or congested, the orientation to the boom, will it need to be turned during the lift, hand off to other personnel at height or down in an excavation, power lines going over them or working close to them, the number of personnel needed, their taglines, their lines of sight to the operator and to each other. Remember, no knots in the body of a tagline or at the tail end of taglines. Mechanical assistance, we may need this like capstan hoists. So always use a rope intended and recommended for tagline use. Wear your gloves when handling taglines. Never wrap a tagline around an arm or a leg in intent to stop a load swing. Keep the spare end of the taglines tidy so not to be a tripping or snagging hazard, and to allow unimpeded paying out as required. Never step into the loop of a tagline. Never place yourself between an immovable object and a load that is not firmly on the ground. Do not position yourself where you can be trapped as the operation proceeds. And if you must, you should release the tagline to avoid becoming trapped or pinch. Be very aware of power lines and the proximity of the lifting operation. Even synthetic slings can conduct electrical charge if damp. On the next slide. Yeah,
sorry,
go ahead.
There's a link there at the end there which you can use for safety posters and the like. Okay, we're back to this again. Let's repeat the poll. Well, I don't know that we're going to get anything a whole lot different than the first time, seeing as nearly all of you decided that we would do it. But let's do it again. Jonah?
All right. Yep. So keep the picture in mind. I'm going to launch the poll right now. And it is open. So we're repeating that same question based on the image as before. And it looks like everybody paid attention pretty well. Overwhelming on the no side. We're getting a couple of yeses coming in. All right, I'm gonna.
Okay, well,
out here. I'll let you address the issues in the picture, Keith.
On the basis that pretty much everyone thought it could be improved on. First of all, this guy is supposed to be supervising the operation. He's not looking at either the guy on the tagline or the crane operator. the beam has been allowed to touch the building, which is not a great idea. One tagline is insufficient in this case. You would hope that they would have had two on here. The angle is too vertical. He's got hardly any control over that load because the line is as vertical as it is. The line is basically too short. And there's probably other things going on there as well. But those are some of the points we wanted you to recognize as being less than perfect, and things that should have been sorted out before they went ahead and made that lift, so they didn't get to where it was hitting the structure. Well, that pretty much concludes the presentation there. I'll hand back over to Jonah, and we'll fend off whatever you've raised.
Yeah, absolutely. Thank you. Thank you, Keith. We do have a couple questions coming in. Get my slide up there. So, looks like here's one from Deanne. She asks, how do you hold the tagline when the load is moving? What is best recommended? What's the best recommended speed the tagline is going through the glove? I don't know if that last part, I read it correctly, but so how do you hold the tagline when the load is moving? We'll start with that.
Start off with gloves on your hand, and when you're paying this out, you don't want to let it slide through your hands. You want to do this hand over hand. It's kind of the same principle that you do turning your car. You know, you don't just let the steering wheel spin through your hands. It's hand over hand. Slow as possible. Don't get in any rush. This is one of the things that I see happening a lot, is people kind of get in a hurry when doing lifting operations. Slow and steady wins the race. Nice and easy. Don't get in any hurry. Don't get in any rush. If things do get that way, just stop and start over.
That's great. Thanks, Monty. We have another question asking about the link that you put up, Keith, in one of the ladder slides there. What I'll do, everybody, is I'll email that out to you. It looked to be pretty long. I don't think I'll be writing it, and nobody will probably be able to read it. So I'll get that from Keith, and I'll email that out to everybody. Also place it on the archive page on the recording. Don't have any other questions right now. I want to just briefly, I'll put my email address, pretty easy, on the screen. If questions do arise, please send them to me, and I'll make sure they're addressed. I can get them to Keith and Monty. It's just my first name. Forgive my second grade writing with my mouse. But jonah@iti.com. And then very briefly, I want to let that stay on the screen for a second. I want to show everybody the way to access the form if you go through iti.com, the website. So we can discard those. So if you pull up iti.com, you see this feedback and support tab right on the right-hand side. Click on that. A new window will open. And then Taglines and Load Control is the first subject there. So you click on that. There we go. And then you're going to want to open it in a new window. And this is a link I'll send out as well, this direct link. I posted it in the chat section of the webinar, but I'll send that out. You can download the presentation file there, and here you're welcome to add comments. Again, looking for constructive peer review, maybe something you didn't realize before that the webinar brought to your attention, or a practice that maybe you guys weren't, the best practice wasn't being followed. So it's pretty wide open. You can post anonymously if you would like. You can add your email address. It's completely up to you, but it looks like it's just past, I'm on the West Coast, so 11 in the morning. And with that, yeah, I think we're good to go. Keith and Monty, if you guys want to sign off or have anything else to say, I'll leave it in your course.
Yeah, I think all I'd like to say is, you know, we welcome constructive criticism, and you know, anything else that people feel may be useful to help them will be added, and eventually we hope to make this thing available to anyone who wants to make use of it. It's not that we want to keep this in-house or anything. We want to just put it out there as something which people might make use of, you know. So thank you all, and with that I'll get offline.
As Mr. Keith said, please send the comments back. I'm interested to see how this comes across. I have a few ideas for some other webinars and publications that I'd like to see out there that everyone can share. Jonah, thank you. Mr. Keith, appreciate all the help. Be careful out there and have some fun. Thank you very much.
Yeah, thanks, guys. Both of you, thanks for donating your time. I mean, great attendance on this one. I hope it was applicable to everybody, and I hope you learned something new. So with that, I think we're going to sign off. And until next time, thanks for attending the Showcase webinar series.